Unit 7, Part 11. I'm going to do some exercises now. Start with 7A, okay? And again, I'll just be running through the thoughts in the order in which you should think them to carry through with proofs. All right, so I've got three premises, right? And my conclusion is down here. I've left a lot of space. It's not F, okay? I've recommended doing doing bottom-up reasoning, which we will, right? Which will be asking, okay, let's just do the bottom-up reasoning, which is the most important, but I'll say something about top-down reasoning in a second. But bottom-up reasoning, right? Enter your mantra, remain conclusion-driven. What is this formula? Not F. Where does this formula appear plus or minus a negation amongst the premises? It appears only in premise 1 as the consequent of a conditional. Straight away, I should be thinking of the rule of modus ponens. Why? Okay, if you don't get there straight away, you should be thinking, which you won't without doing lots of practice and doing lots of exercises. But the thought is, okay, it's the not F, that's the consequent of a conditional. That's the consequent of a conditional that I am given as a premise, right? What rule allows me to move from a conditional to the consequent of the conditional? And that rule is modus ponens, but you can only use that rule when you satisfy the second of two conditions for the application of the rule, where the two conditions for the application of the rule are the two premises of the rule, right? So I'm given as a premise the conditional, but to apply modus ponens and derive, as I want to, the consequent of the conditional, I need the antecedent of the conditional, right? So I'm off with my proof. I'm off the mark. I know where I'm going. I know what rule I'm going to use to get my conclusion, right? I'm going to put it over here. This is me working backwards. So not F, that's my final conclusion. I'm going to get there, it looks like, by modus ponens. What formula do I need to derive that, right? Well, I need the antecedent of the conditional, right, to satisfy the second premise. So I need C and D, okay? And if you can do that thought, good, because all you need to do proofs is repeat that thought over and over again. Let's apply the same working backwards thought to this formula now, right? See where you are. You're in a place that says, this is what I need to get home, right? So all I need to do is say, treat this as if this was your conclusion, right? Ask, what is the form of this formula? Okay, it is a conjunction, right? So here I'm thinking, probably, I'll elaborate on the probably in a moment, but probably I'm going to derive this conjunction by the rule of conj. Why? Because, well, okay, what is the form of this? It is a conjunction. What rule has as its conclusion the conjunctions? It's the rule called conjunction, right? So that part, when I say what rule has as its conclusion formulas of this form, think of what the rule is. The rule, whenever you're writing down a rule, right, doing a justified step, citing a rule, what is the formula you're putting down here in your justified step as you lay out your derivation, lay out your proof? The formula you're putting down is the conclusion of that rule, right? It's the conclusion of that rule. So that's why I'm asking, when I see that I need to get home, I need a conjunction, I ask, what rule has its conclusion conjunction? A conjunction. Well, it is the rule of conj. And now that tells me, right? That gives me the information of what I need to get to derive this. If I'm going to get this by conj, how do you get conj? Well, I need to think of what the nature of the premises of the rule are, because that's what I need to satisfy. I need to get the premises. So that's just, I need to somehow get C and somehow get D, right? In my proof is going to be, I want C to appear somewhere, and I want D to appear somewhere, and then I can derive this. So now I'm doing this, arrow, right, CD. How do I get them? Okay. I could keep going, right? I'll ask, where does C appear? Where does D appear? Sort of all over the place, but you could, it would be fine to keep going and working backwards and asking the same question over and over again of how you're going to get C out, but you can also get, it's also going to turn out that we can get what we need by doing top-down reasoning, and I want to say some things about top-down reasoning because there are some habits that you should be in proofs which apply here, which can be illustrated here. But first, let me say one thing. It's a bit of a complication, but when I said, when we were at C and D, I said, you ask yourself the question, okay, this is my elaboration on the word probably that I said I'd come back to. I said, given that that's what I need, I'm probably going to derive that by conjunction. Conjunction is the only rule we have that has a conjunction as a conclusion. So it's probably going to get that by C and D, by getting C independently, getting C by itself, on a line by itself, getting D independently on a line by itself, citing those two lines when I write C and D and form my conjunction. Be writing C and D, justification, conj, and then the two lines upon which C and D appear. That's probably how I'm going to do it. Only probably, because you might have a situation like this. You could have amongst your premises, right, A hook C and D. Right? If you had something like that, I've got A and I've got A and C and D, right, appearing, like that, right, then I would get C and D not by conjoining C and D, but rather by modus ponens, right? So this formula appears as this formula as a whole appears as a subformula of another formula, right? And in this case, I can bust off this formula by itself by a simple modus ponens. This lesson will come back to when, especially in Unit 8, especially in the distinction between the pure quantified, the pure proofs, and then the mixed ones. Difference between questions 2 and 4 of Unit 8, I think, or am I mixing up? Yeah. Anyway, we'll come back to that difference. But the point is, you need to be on the lookout for different ways you might get this. So it's not necessarily the case that because this is conjunction, you'll be getting it by conj. That is one possible way, and that might be the way you need to do it. But it's also possible that that formula, the whole C and D, appears as a subformula, which you can bust out. For example, if it appears as the consequent of the conditional, and you have or can otherwise get the antecedent of the conditional. Notice here, C and D does appear as a whole, as a subformula of this, but since it appears as the antecedent, if it was the consequent of a conditional, it would be easy to get, or it might be easy to get, but as a conditional, it's the antecedent of the conditional. Oh, sorry, no. Sorry, I've confused myself because we figured out we needed C and D because of premise 1, right? We needed C and D because we want to do modus ponens on 1, right? Forget that last bit. Okay, let me explain the top-down reasoning. Okay, whenever you see formulas that are conjunctions, it should be second habit that you simplify. Use the rule of simplification, and here you're going to use it several times. Okay, so first of all, the obvious one is 3 is a conjunction. The rule of conjunction is whenever you're given a premise, the rule of conjunction is one premise and a conclusion. The premise is a conjunction, right? It's P and Q, therefore you're entitled to infer P, also you're entitled to infer Q. Notice on the inside cover, there's 2 forms of simplification, right? So from 3, right, that premise, A and B, right? 3 simp, and same justification for this, 3 simp. I've got A and B by itself. Notice premise 2 is a conjunction. You need to see, even though it's complex, it's a conjunction with complex conjuncts, nonetheless, you need to see that as an instance of P and Q, that is, a application of simplification waiting to happen, right? So 6 and 7, this is my second nature move. As soon as I see conjunctions, I'm going to do this. It's top-down reasoning, right? I've got A and C, 2, simp, and I've got V, hook, D, 2, simp, right? And as